Okay, so this is your second video, maybe third. All right, so let's get this started because I don't want to make it too long. So the first question said, divide 231,111 by 9, and it also tells you to explain whether it's divisible by 9 or not. So let's start with that. So the trick, one trick that you can use to see if the number is divisible by 9 is to add up all the digits. So we're going to add 2 plus 3 plus 1 plus 1 plus 1 plus 1. And I get 2, 5, 6, 7, 8, 9. And the sum of the digits is 9. If the sum is divisible by 9, then the whole number would be divisible by 9. So what I'm asking you to write here would be exactly that. I added all the digits. And if the sum is divisible by 9, then the whole number would also be divisible by 9. In this case, it is. So when you divide here, you shouldn't see a remainder at all. So let's see if that works out. 923, 2. 5 left over, bring that 1 down. 5 into 51, 5 times, which is 45. 6 left over, bring the second one down. 961 is 6. 54. 7 left over, bring the third one down. 971 is 8 times, which is, not 8, sorry, would be 7 times, which would be 63. That gives us 8 left over. Bring the last one down, and 9 into 81 is 9 times. So, as you can tell, no remainder. So, final answer is what? 25,679. So that's what I would expect to see. Okay. Moving on. What divisibility rules could you use to determine if 157,536 is divisible by 55? Well, the divisibility rules that I would use, well, I know that 55 is made up of 5 and 11, so I'd use these two. If it works for 5 and it works for 11, then the whole thing would work for 55 as well. So let's see. For divisibility rule for 5, we look at the last digit. If it's a 0 or 5, it's divisible by 5. So for 5, it doesn't. So already I know that this whole thing is not going to work, but I'm just going to do 11 anyway. So to check for 11, let's see. Let me write the number again. The rule for 11 is a little weird, right? So I'm going to take the first number, the third, and the fifth, and I'm going to add those up. So I get 1 plus 7 plus 3, which is 11. And then I'm going to take the remaining ones, which is a 5, another 5, and a 6. 5 plus 5 plus 6, and that gives me 16. And if I find the difference between these two, I get a difference of 5. And that's definitely not divisible by 11, because it has to be 0 or 11. So it doesn't work for 11 either. So I know when I divide this, I will definitely get a remainder. Okay, so let's see if I can do this right. 55 into 157, 2 times, 110. 4, 7, bring the 5 down. I think that's going to be an 8. I'm not too sure. I'm going to do it on the side here. 55 times 8, 440. So 8, 4, 4, 4, 35 left over. Bring the 3 down, and that looks, 7 might be too much, so definitely a 6. 330. And I'm going to get a 23 left over and bring the 6 down. That looks like maybe a 4. And that's going to be 220. And that's, I think I'm right. So 220 and 16 left over. So my final answer, you can write as a fraction. You can leave it like that. It's your call. I don't mind either way. So you can write 2,864 remainder 16 or 2,864 16 over 55. That's okay with me. All right. Moving on. 3. El número 3, it says, let's divide using that other method I showed you in class. So with this one, I'm going to do this one first and then see if it matches the right one. So for 1,000, how many thousands do I have? I had 1, 2, 3, 4, 5, 6, 7, 8. How many hundreds? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many tens? 1, 2, 3, 4, 5, 6. And I have 8 ones. 4, 5, 6, 7, 8. So let's start here. Can I make a group of 8? Can 8 fit in here? Yes, I can. So I can make one group of 8. Let's move on to 100. I have 9 hundreds. So can I make a group of 8? I can. And I'm going to have, because there's 9, I'm going to have 1 left over. So definitely one group of 8. And this leftover 100, remember, shifts over this way, and it becomes 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tens. Can I make a group of 8? I can make 1, 2, 3, 4, 5, 6, 7, 8. I can make one group over here. That's 8 inside. And then do I have 8 left over? 1, 2, 3, 4, 5, 6, 7. Yeah, and I can make another group of 8. Nice. So I can make 2 groups of 8 in the tens. And in the ones, one group of 8 exactly. So this number actually works out nicely. There's going to be no remainders. Okay. So let's see. 8 goes into 8 one time. Bring the 9 down. One group of 8 in the hundreds. Subtract, 1 left over, bring the 6 down, 16. I got 16 tens, so I can make 2 groups of 8. And finally, I'll bring the 8 down, and I can obviously make one group of 8 ones. All right. Final answer, 1, 1, 2, 1. And you notice that this and this are exactly the same. I like this. I know some of you had a little trouble, but it's a nice way of showing division. Number 4, we have a big number here, and I'll write it here. 5, so 3, 3, I'm going to put it blank, 2, 2, blank. So I need to fill in this spot and this spot with 2 numbers so that it divides by 3 and divides by 5. So one thing I know is if it's going to be divisible by 3, I got to add all these digits, including the ones that I'm still haven't put in there. Has to be divisible by 3, and the last digit can be a 0 or 5. So why don't we do this? Why don't we put and make the last digit a 5? Make the last digit 5. Okay, I know it's divisible by 5. So divisible by 5, check. I know that. To make this whole thing divisible by 3, I gotta add these and divide by 3. So let's make it so that the sum is divisible by 3. So what do I have so far? So far. 5 plus 3 is 8. 8 plus 3 is 11. 11 and 2 is 13. 13 and 2 is 15. 15 and 5 is 20. So far I have 20. That's not divisible by 3, but if I add plus 1, it's going to give me 21, and 21 is definitely divisible by 3. So if I add a 1 here, this whole number would be divisible by 3. Let's check again. 5 and 3 is 8, plus 3 is 11, plus 1 is 12, 13, 14, 15, 16, and 16 plus 5 is 21. And 21 is divisible by 3. So this number right now is divisible by 3 and by 5. So that's one possibility. Let's do another one. Again, I'm going to write it. 5, 3, 3, blank, 2, 2, blank. So let's make it divisible by 5 and by 3 again. So to be divisible by 5 has to end up in a 5 or a 0. So this time around, I'm going to put a 0. Okay, so let's see what I have as far as sum. 5 plus 3 is 8, plus 3 is 11, plus 2 is 13, plus 2 is 15. So the sum right now, as it is, it gives me 15, and 15 is divisible by 3. So I really don't have to add anything. I could put a 0, and that would have been okay. Or if you wanted to add a 3, give you 18, and that's divisible by 3. You could add 6, that's going to give you 21. So let's just make it simple. You don't have to complicate things. Let's make a 0 here. Okay, so if I make that a 0, 5 plus 3 is 8, plus 3 is 11, plus 0 is 11, 11 plus 2 is 13, plus 2 is 15. So this whole thing adds up to 15. Is that divisible by 3? Yes, it is. So my second number is 5,330,220. Okay, and there's your 2 different possibilities. You definitely could have had more, but those 2 are enough. Find all the factors of 96. So let's do that, and we did that in class. And again, your times table, super handy. 1, write it in pairs, comes with 96, because 1 times 96. 2 will work because I know it's even, 48. 3, yes, it will work because 9 plus 6 is 15, and 15 is divided by 3. So 3 and something. 3 and, let's see, 96 divided by 3, 32. 3 and 32. 4 will also work, and 4 is going to be 14. No, 24. 24, 4 and 24. 5 won't work. 6 will also work. 96, 6 is going to be 36, 16, 6 and 16. 7, no. 8 will work. 8 and 12. 9 won't work, 10 won't work, 11 won't work, 12 will work, but I already wrote 12. So if I repeat a number that's already listed, then I know I'm done. So here are all my factors of 96, and there's a lot. So it's composite. It's not an IMERP because it has to be prime to begin with, and it's definitely not a perfect square because there's no two numbers that are the same that multiply that give you 76. 71, I get 1 and 71. 2, no, 3, no, 4, no, 5, 6, 7, 8, no, that's it. 1 and 71 is just two factors, so that makes it a prime number. Is it a perfect square? No. Is it an IMERP? Yes, it is, because if I take 71, switch the digits, it becomes 17. 17 switched around, it's also prime. So prime and IMERP. 72. 1 and 72. 2 and 36. 3 and 24. Yep, 3 and 24. 4 and 18. 5, no. 6 and 12. 7, no. 8, yes. 8 and 9. 10, no. 11, no. 12, it's already written. Now I know I'm done. So all these. So this is definitely composite. Not an IMERP and not a perfect square. 64. 1 and 64. 2 and 32. 3, no. 4, yes. 4 and 16. 5, no. 6, no. 7, no. 8 and 8. Okay, 8 and 8. 8 times 8, 64. So 9, no. 10, no. 11, no. 12, no. 13, 14, 15, 16. Okay, so this is a composite for sure. More than two factors. It's not an IMERP, but it's definitely a perfect square because of this guy right here. 8 times 8 gives you 64. Okie dokie. Let's move on. Second page. So this one is okay. Let's see. All right, we did this in class, so let's do the easy one. 14 squared. Squared means the second power, right? Expanded form would be 14 times 14, and write that down. 14 times 14. The extended form would be 196. 10 to the 9th power would be 10 to the 9th power. And I'm going to write 10 times 10. 9 times 3, 4, 5, 6, 7, 8, 9. And we know the little trick with 10. It needs to have 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Done. 1, 2, 3, 4, 5, 6, 7. So that's 2 to the 7th power. 2 to the 7th power. And that's, let's see, 2, 4, 8, 16, 32, 64, 128. And this is 343. Ooh, this might be a little tricky for you guys to figure out, but this is 7 times 7 times 7. And word form would be 7. What's another word for third power? Cubed. Okay. Hang on a second. Oh my god. So, sorry, 7. You can write 7 to the 3rd power or 7 cubed. That's the short way, okay? Cube stands for exponent of 3, okay? That's it for that part. Ooh, this one is a little more complicated. Use divisibility rules. If the number is divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, put an X. All right, so 462, is it divisible by 2? You know what? You can, yes. Is it divisible by 3? Yes, because it adds up to 12. Is it divisible by 4? No. By 5? No. By 6? Does it work for 2 and 3? Yes. If it works for 2 and 3, it works for 6. 7. Double the last number. So for 7, the trick is, okay, we haven't done 7, you double this number, which is 4, and I subtract from 46. So 46 minus 4 is 42, so that's definitely divisible by 7. So 7 is a yes. 8, you look at the last 3 digits. Nobody likes the rule for 8. 8 goes into 46 5 times, which is 40. 62, no. 9, no. 10, no. 11, if I do 11, remember I take the first one, skip, so add these two. 4 plus 2 is 6, and then I subtract it from whatever's left over, which is this, minus 6 is 0. So if the answer is 0 or 11, then yes, so definitely a yes. For 12, did it work for 3 and 4? It worked for 3, but not for 4, so 12 is definitely no. 1056, yes, yes, because it adds up to 12. 4, yes. 5, no. 6, yes, because it worked for 2 and 3. 7, 105, so double the last one. 6, double that is 12. I'll subtract that from 105. I get a 3, and 10 minus 1 is 93. Is that divisible by 7? No. So 7 is a no. 8, 8 is a yes. 9 is a no. 10 is a no. 11 is a yes again. And 12 is a no. Actually, 12 is a yes because it worked for 3 and 4. 647, no. No, 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 no. 14, 54, no. 8, no. 9, no. 10, no. 11, definitely no. 12, no. Wow. 480, yes, 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 yes. 7, no. 8, yes. 9, no. 10, yes. 11, no. 12, did it work for 3 and 4? Yes. And there you go. Okay, so that is what I would like to see. Okay, and the next one, primes under 100. Okay, so let's start writing all the prime numbers, and obviously if you have your notebook, you can, but you're not going to have your notebook, so try to memorize. 2, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and the last one, 97. All right, so those are your first prime numbers, less than 100. Okay. Find the prime fraction of 360, so we're going to break it up. I'll do it here. 360, I'll break it up in 36 and 10. 10, I'll break it up in 2 and 5. Circle, circle, because they're prime numbers. I can't break it anymore. 36, I'm going to break it up into 4 and 9. 4, I'm going to break it up into 2 and 2. Circle, circle, because they're prime and I can't cut anymore. And the 9, I'm going to break it up into 3 and 3. So, another way of writing or saying 360 is 2 times 2 times 2 times 3 times 3 times 5. I'm going to take advantage of our exponential notation and make that shorter. 2 to the third times 3 to the second times 5. Okay. Next one, 1020. Yikes. 1020. So again, easy to break. I'll take that 0, make that a 10, and the other half I'll make 102. 10 is 2 and 5. Circle, circle. 102 is, well, divided by 2 works, so 2 and 51. 51 could be, let's see, 17, 3 and 17. That one's a tricky one. 17 is a prime, so I can circle. So this would be 2 times 2 times 3 times 5 times 17, or 2 to the second power times 3 times 5 times 17. Notice I'm writing this in order from least to greatest, the 2, the 3, the 5, and 17. Okay. 14, find a number that is less than 100, which has 6 factors, of one of which is 21. So there's this number over here that if you do that factor thing, one of them is 21. One of which is 21. So let's see. I don't know what the other pair is. So let's pretend that 21 came with 2. 21 came with 2. My mystery number would be 42, right? Because 2 and 21 is 42. So 1 and 42. I can add that now. Is there anything else that multiply give you 42? Yes, there is. 6 and 7. I have 1, 2, 3, 4, 5, 6. Oh, that was easy. So just make sure that 42 has no other factors, because if it does have more factors, then this is not the correct answer. 1, 2, 3. Oh, there is a 3. 3 and 14. 3 and 14. So my answer is incorrect. So this 42 is not the answer I'm looking for, because it has now 8 factors. So oopsie. So let's try another one. So I don't know what my mystery number is. I know one of my pairs is 21. So let's try 3 and 21. 3 times 21 is, let's see, 21 times 3 is 363. So let's pretend the number is 63. So I got 3 and 21, which means I have 1 and 63. 2 doesn't work because it's not even. 3 already have. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7, yes. 7 and 9 is 63. 8 doesn't work. And 9 that's already written, so I know I'm done. So I have 1, 2, 3, 4, 5, 6. So my actual number was 63. Okay, find a number less than 100 that has 6 factors, one of which is 14. Okay, so again, there is a number here that has a bunch of factors, and one of them is 14. So let's try, well, 14 is going to pair up with someone, right? Let's pair up with 2. So if I pair up 14 with 2, it means that my number that I don't know is 28, right? Because 2 and 14 is 20. So let's see if it's true. So let's start finding all the factors. 1 and 28, 2 and 14, 3 no, 4 yes, 4 and 7, 5 no, 6 no, 7 is already said and written down. I can stop. So 1, 2, 3, 4, 5, 6. So one of the numbers is 28. That's another one. So let's see what the other one is. So again, don't know what the number is. I know one of the factors is 14 and the factors come in pairs. So let's pair 14 with 3 this time. 3 and 14. So 14 times 3 gives me 42. So let's pretend the number is 42. 3 and 14, which means there's a 1 and 42. 2 and 21. 3 and 14. 5 is no. 6. Oh, darn. So 6 comes with 7. So that makes it 1, 2, 3, 4, 5, 6, 7, 8 pairs. No. 8 factors. So that's not it. 3 and 14 is not it. So let's try 4. Again, don't know the number. Let's try 14 is one of the factors. Let's pair that with 4. 4 and 14, 4 times 14 is 56. Let's see if that works. So there'd be 1 and 56, 2 and 28, 3 no, 4 and 14, 5 no, 6 no, 7. Oh, gee, 7 and 8. So again, 1, 2, 3, 4, 5, 6, 7, 8. So that's not going to work. We tried was 4, so let's try this 5. 54. So 14, and let's pair that with 5. I don't know what my number is, so 14 I knew it was one of the factors, and it comes in pairs, and let's pretend it came with 5. 5 times 14, 70. So let's pretend the number is 70. So it's 1 and 70, 2 yes, with 35. 4, 2, yeah, 3 no, 4 no, 5 yes, 7 yes, 7 and 10. So that's more than, again, so that's not going to work. I got to finish this video. So we tried 5, right? Try 5, so let's try 6. 14 and 6. That's 84. 284. Oh, that's going to have a lot of factors. 14 and 7. No. Did I miss a number? 84. So let's try 84. So if it's 14, this is 6. 1 and 84. 2. That's also saying I'm missing something. Alright, so I don't want to make this video longer than it is. So if you have a different answer than I already got, one of them is 528. If you find the other one, let me know. 16. Always, sometimes, or never. So I want to choose whichever one is the appropriate one for each sentence. Is it always true? Is it sometimes true, or never true? Okay. If a number is divisible by 3, then it's also divisible by 9. Is that always true, sometimes, or never? Well, let's pick numbers. Let's pick a number that's divisible by 3. 15. Is that divisible by 9? No. So it can't be always true. Is there a number that's divisible by 3 and also divisible by 9? Well, let's pick 9. Is 9 divisible by 3? Yes. Is 9 divisible by 9? Yes. So sometimes that rule, actually, you can say that sometimes a number divisible by 3 is also divisible by 9. So this would be sometimes. Not never, but sometimes. All prime numbers are odd. Is that always true? Sometimes or never? Are all prime numbers odd? What's your first prime number? 2. Is that odd? No, it's even. So this sentence is not always true. Is it never true? No, but sometimes it's a positive. Well, I'm going to say sometimes, but on one occasion. So this is also sometimes. All perfect squares have 3 factors. Well, let's pick a perfect square, 25. You get 1 and 25, and then 5. It has 1, 2, 3 factors. So far, so good. Let's pick 16, which is another perfect square. 1 and 16, 2 and 8, and 4, because 4 times 4 gives you 16, right? So that's already, it can't be always true that it has 3 factors. So sometimes, like in 25, or let's try 9, 1 times 9 is 9, 3 times 3 is 9, so this is a perfect square, so this one has 3 factors. So sometimes perfect squares have 3 factors, so this is also sometimes. If you multiply a prime number by 2, the product will be a prime number. Ugh. Let's take the prime number 2. If I multiply it by 2, will I get another prime number? No, because 4 is not. Let's pick another prime number, 5. If I multiply by 2, will I get a prime number? No. Pick another one. 17 is a prime number. If I multiply that by 2, I get 34. Is that a prime number? No. Let's pick another prime number. Let's just try it out. 23 times 2. It's 46. Is that a prime number? No. So apparently, this never happens. So if you multiply a prime number by 2, it will never be another prime number. Okay, so try to disprove or prove the sentence before you decide if it's always, sometimes, or never. Various times, okay, because it might work for some, it might not work for some. So do examples until all the examples match the sentence, or all your examples don't match the sentence at all, or sometimes match the sentences. Okay, so, I forgot that word. I told you. So if you're watching the video, usually I write it under before. So this time, I'll write the word right here on top. And our word for the day is, okay, and this will be your bonus point words. Happy Friday. Okay, that's it.